All right, everybody. So we just had a class where I introduced the base case building of a systems model in Vensim. In retrospect, I wish I had recorded that lecture, but I didn't. So here I am instead recording a video. I am going to start with the model that I built in class and just review it for you. And then we'll keep building. And so you can see me build using these tools in real time, and you can go and pause this recording, rewind and go back and things like that. So let's just review the model that I've built here. I'm going to start by clicking on this equations tool so that I can show you how I've defined each of my variables. I started with a stock of organic dairy operations. And I have said that this stock is going to start with an initial value of 750 operations. And I got this from a peer-reviewed article written by McBride in 2010. It's a study of dairy farm conversion from conventional to organic. And in their study, they had 2,987 dairy farms, 750 were which were organic. So I'm going to use that as my starting value. This is a level type variable measured in farms. And I've said that the way that we add to organic dairy operations is through market entry, and market entry is defined as the sum of new organic farms as well as a conversion of farms from conventional to organic. So it's the sum of those two ways that it can happen. And this is going to be defined as an auxiliary type variable where the units are farms per year, because this is a flow. So the flow, I'm looking at how many farms I'm going to add every year in my simulation. So new organic farms to begin, I'm setting this as a constant 0 just to keep my model simple. However, I could go out and look in the literature to determine how many new organic farms are established every year and then use that here as an equation. But just for simplicity right now, I'm keeping it as a constant 0, which I could change later. The key piece here is the conversion from conventional dairy operations. So I needed to create another stock. I have a stock here, which is conventional dairy operations. In that same peer-reviewed article, McBride 2010, in their study, out of the 2,987 dairy farms that they looked at, 2,250 of them were conventional. So this is my initial value for the number of conventional dairy farms. Again, this is a level stock variable measured in farms. And now I'm going to say that this one has an outflow based on the number that are converting in a given year to organic. So conversion to organic, I'm going to enter as a percentage. So here, conversion is an auxiliary variable measured in units of farms per year. And it's going to be the number of conventional dairy operations multiplied by a conversion rate. And that conversion rate is going to be some percentage of those conventional dairy farms that convert to organic in a given year. So again, I got this conversion rate from that same piece of literature, McBride 2010. On page 9 in that article, they say that between the years 2000 and 2005, they saw that the number of organic milking cows increased by 25% annually. So that's what I'm using as my initial conversion rate. Okay, so I've defined all the variables and the connections in my model. And when I run the model with a base case of a conversion rate of 25%, you see that this is measuring organic dairy operations. It starts at 750 and then it steadily climbs over time until it reaches dynamic equilibrium. And dynamic equilibrium here happens because I've defined organic dairy as only coming from conventional dairy. And I started with 2,250 conventional dairy operations. So if the only way we get organic dairy operations is from their conversion, then there's going to be a point in time in which we cannot convert anymore, right? That this conversion is done because all of the conventional farms have been converted to organic. So then I ran the same model, but I increased the conversion rate to 40%. And you can see that the number of organic dairy farms, because the conversion rate is higher, it climbs faster and still reaches dynamic equilibrium, actually approximately in the same time period, around 17 years, which is the point at which all conventional farms have been converted to organic. I'm going to run another simulation here. I'm going to call this base case 10%. So you can see how I've altered this. So I'm going to synthesize this simulation and then drag my slider on conversion rate from 0.25 down to 0.1. That's close enough. And now you can see that the blue line is my like current simulation. So I'm going to stop it here. And I want to look specifically, I want to highlight the area. No. Okay, so I'm going to reset my scale. I want to highlight the area of my graph that I'm most interested in, which is this. So I can see that in year 0, we start with 750 organic farms, and that when the conversion rate is only 10%, the growth is much slower. And we reach dynamic equilibrium much later. So we don't see full conversion of conventional dairy farms to organic dairy farms until over 40 years from now. So it takes a lot more time for that conversion to happen. And that's what I'm interested in seeing overall, right? Like I want to slow the conversion of conventional to organic so that we can keep organic operations small and maintain animal welfare. So this is kind of my base model. And I know that my way in that I want to address through policy is that conversion rate. And so I'm imagining that the way I'm going to affect the conversion rate is people will be less likely to convert from conventional to organic if it costs them more to do so. And the way it's going to cost them more to do so is if I increase pasture requirements, the number of days that cows have to go to pasture, because that's expensive. That's more expensive than keeping cows in a milking parlor. So there's a lot of pieces here. So this is where I start to build out my model. Okay, so I know right away that the conversion rate is going to be based on cost, and the cost is based on the number of cattle, right? The number of cows that you have. So I am going to create a stock by clicking on the stock button here. And I'm going to call this cows. And there's going to be an inflow that I'm going to call acquisition. You'll understand why in a second. And there's going to be an outflow called loss. Okay, and this is because there are a couple of ways to build your cow stock. There is births of cows, right? So there's going to be some component that is related to the birth rate. And that's an auxiliary variable, and it's going to impact how many cows you have through what I'm calling acquisition. But also, if you're a dairy farmer, you get new cows from your existing cows giving birth, but you also can get new cows by buying them. So I'm going to call this other auxiliary variable purchase, and that is going to impact acquisition. Okay, so there's two ways that you acquire cows. They're either born or they're purchased. If they're born, it depends on the number of cows you already have. So this is a feedback loop. There's a feedback loop that says that the number of cows is going to affect your future acquisition of cows. So there's a feedback loop. All right, so now let's define these things. Let's say you start, this is a level variable measured in cows, and let's say you start with 100 cows. Now you acquire cows in one of two ways. You have birth of new baby cows, which is going to be how many cows you currently have times the birth rate. This will tell you how many new cows are born. Plus, you have the cows that you purchase. And so this is an auxiliary variable, and this is going to be cows per year. Okay. And so this birth rate is per year birth rate that I don't even know. This is where like I need data. I'm literally making up a birth rate here. This could be totally off. I need to do my research about how the birth rate of cows. So I'm just going to start it with 0.03 as the birth rate. Unable to understand the units of measure. So because this is a birth rate, this is maybe actually it's cows per year, which makes it an auxiliary variable, not a constant variable, but it is a constant. Let's see if it likes that. And then purchase, I'm going to make this really simple. I'm going to keep the constant 0. Just saying, I'm going to make the assumption at first that you're not buying any cows, just for right now. So this is okay. And then loss has to do with a natural death rate, but also you're going to sell some cows and you may lose some cows to injury or disease. Let's say right now, I want to keep this really simple because I'm not sure how this model is going to run. Let's say I lose 5 cows per year on average. Okay, so now everything's been defined. I want to look at my cow graph to make sure this is working properly. So I'm going to call this base case cows. And simulate it. Then I want to look at a graph of cows. Okay. Just so I can see how this is working. All right. So, I need to go back in and define cows because cows can't go negative. So I've got to put them in at 0. And I start with 100 cows. So let's try this again. Yes. So there, I start with 100 cows. Why is it here? my loss, this is where like it's good to check these graphs, is at 5 per year. My acquisition, why is it only going down? So this is saying that my out, if it's going down, I know that my outflow is bigger than my inflow. Let's delete this and try again. So let me double check things. So I've got cows at 100. It's acquisition minus loss. Okay. Acquisition is the cows that are born plus the cows that I'm going to purchase. The loss, I'm just going to make sure that my birth rate is working correctly. So I want to put this here and have my cow graph. It's decreasing. So that says my birth rate is wonky. This is where, what is an appropriate birth rate? What if it's 0.3? Let's look at what that does. I want to simulate that. Okay, so now it's doing funky things. What is an appropriate birth rate? Maybe this needs to be an auxiliary variable instead of a constant. Let's try that. This is like I have 0 cows until I have a shit ton of cows. What's happening? This is why you build your model slowly. Okay, I paused the recording to try to figure out cow birth rates. And I shut down the software and reopened it. And lo and behold, some magic happened. I'm going to save this before it gets too out of hand. So you can see here, let me define my variables for you. We start with 100 cows. We are going to assume we lose none of them, just to keep things simple right now. I've given a birth rate of 3%, 0.03 cows per year, and then defined the acquisition of cows as cows times the birth rate plus the purchase where we're not purchasing any. And you can see that since we're allowing our cows to repopulate themselves, give birth, I have an increasing number of cows over time. Phew. So this is where like this model can be wonky. The software can be having hiccups. When in doubt, like revisit your variables or like start it again. I think something was happening where when I was simulating it, it was taking data in the wrong way. So I really didn't change anything. I just reopened it and this is how I want cows to look. Point being, I've built out another subsystem that's cows. Now I also have to figure out here how to add in the cost of feeding these cows, because that's how I'm going to affect conversion rate. So I think I'm going to build a stock, which is the cost of feeding. And I'm going to say that there are basically 2 things that go into the cost of feeding. And I don't know if these are a flow per se. Not really. they're not really a flow, because when I think about the cost of feeding, I'm not building up. It's just like it is a level. You're seeing me think through this in real time as I'm building my model. I don't know if this is correct, but this is my initial thought, is that I've got one flow. Is it a flow? That's feeding that happens from grasses. And then there's also a flow that's supplemental feeding. So it's like all the stuff you give other than grass. And now I've got too many things. All right. And so now if I think about this, it makes sense that it's the cost of feeding is the cost of grass plus the cost of supplemental feeding. And this is going to be in dollars. And the initial value for the cost of feeding is going to be 0. And so the cost of grass really depends on where that grass comes from. So there's going to be percent from pasture. This is where my pasture requirements are going to come in. And then there's going to be percent from barn. So you can feed grass to cows without allowing them to go out into the pasture. You just bale it up for them and then feed it to them. So the cost of grass is going to be dependent on how much comes from the barn and how much comes from pasture. And this is where I need data on the cost of these things, right? I've got to like go and look at like, what does it cost to feed some cows and find some information, but I'm just building my model right now. Okay. I'm going to stop the video here because this is what I want you doing this week, is thinking about the system, recognizing where you need to be more intimate with the system, where you need resources, where you need data, making sure that your system components work independently. So like right now, I can't even run this model because you'll see if I was to press the equation button, I have a bunch of undefined variables. So the other stuff won't run. You have to define everything before you'll run it. So that's why it's like good to build. You saw how I built, I built this subsystem with market entry first and made sure it ran. Then I added another subsystem of cows, made sure that ran. Now, what the next thing I would have to do is make sure this subsystem runs. Then I can connect the subsystems, but make sure each individual subsystem runs independently first before you try to connect them. Because where I'm going with this is there's going to be somehow where my conversion rate, which is right now a constant, is actually going to be an equation that depends on how many cows you have and what it costs to feed them. More so to be continued. I'm doing this in real time with you. This would be a great place to land for you next week. Make sure you have at least one little subsystem that runs. If you have more than one subsystem that runs, that's great. Not necessary. The next week, I'm going to expect that you have multiple subsystems. The following week is when we'll connect it. So one step at a time, make sure each subsystem runs. I hope this was helpful in the sense that you got to see like where I clicked for things. Questions, comments, concerns, please email me. And it's a work in progress. Be kind to yourself. And we'll see where this goes. See you next time.